In this section, we begin our exploration of loops within the Bash environment. Now, Bash by default supports three basic types of loops: for loops, while loops, and until loops. We'll begin our exploration with for loops. They're the easiest to understand, and they're very useful. All the loops are useful, but you need to understand for loops. Now, you'll find for loops throughout programming languages, so get used to them if you're not already. Now, let's open a shell, and we'll begin scripting away to show you how for loops work. We'll navigate into temp 2, that's where we've been operating, and we want to create a file essentially to run our very first loop. So let's see if we have anything already. Nothing exists. So we'll touch a file, we'll call it forloop1.shell. This should be fine. We don't need to flag it executable. Let's modify it using Pico. And we'll set this file up with our shebang header. Point to the interpreter. We'll end it. And we'll put in some basic information, such as author, date, etc. And we can hook up the rest later. Now, how do we go about writing for loops? Well, the very first loop that we're going to write is going to cycle through a list of a few countries. We'll start with 3 countries so that you understand how loops work, for loops work within a Bash environment. The default operation for a for loop is to cycle through a list and to assign each element of that list to the argument, the current argument. So the basic syntax for a for loop within the Bash environment looks as follows. For argument, now argument can be any variable that you set. So for argument in list, and we'll denote list within brackets, do, if it's on the same line, you separate it by a semicolon, and you put the action item here, action item, and then you end it with done. So the basic way, or the basic operation of a for loop within a Bash environment is as follows. For whatever argument you set, it is equivalent to the first element or each element of the list as it cycles through the list. It assigns that value to the argument, and then it does something as a result, such as echoing the argument. That's a common usage of a for loop, to set a value to the argument as it cycles through the list elements and then do something based on the current value. So let's show you a real example. This is the basic syntax. We're going to set up a for loop for a list of countries. Let's set an argument. We'll say for countries in, and we'll specify 3 countries. We'll put USA, Australia, France, and we can begin with 3. There are no limits. Now, if you'd like to write this entire thing on one line, or to include the do operation on the same line, you need to terminate the for section with a semicolon. Ideally, you should separate, for visual sake, or for visual purposes, you should separate the for section or the for line from the do line. And when you do so, you don't require a semicolon. So for countries in USA, Australia, France, do the following. Now you can separate the do from the actual action item. And it's nice to separate the lines and to begin with a tab so it's nice and clean. Now we're going to do something, and we'll do something that's simple. We'll simply echo the variable, the current argument, countries. And we don't have to do anything else. We can just end the loop and put done. Here's a basic for loop. It doesn't look like much, but once you understand this premise, then you can go on to more sophisticated examples, such as cycling through directories, cycling through a sequence of numbers, setting counts, opening files, going through the lines, which we'll do. We'll show you some examples. So for countries in USA, Australia, France, do the following, which is to echo the countries. Now, there's a lot more we could do here. We haven't shown you conditions yet, like if, then, else. But for example, let's say the country were USA. We could do a test. If country equals USA, echo you're in America, or something to that effect. Well, also keep in mind that the list definition here is pretty subtle. These are 3 separate values, USA, Australia, and France, separated by a space or by white space. They're treated by the for loop as separate list elements. So these 3 items, USA, Australia, and France, are treated as if they're separate rows in a file or separate rows in a database. They're totally different values, totally different records, although on the same line. Excellent. So this is what constitutes a for loop. Let's show you how it works. We'll exit, and we'll source this file. Now, there are a few ways we can, well, two ways we can source a file. We've shown you. You can use source, or you can just simply type dot and the name of the file, the script file, in this case forloop1.sh. Now look at the results. It cycles through, it echoes USA, echoes Australia, echoes France. That's a basic for loop. Now let's do some more with this particular loop. We'll modify it. If you wanted, you can add an additional country to this loop. Let's add Latvia, for example. Let's add something else, perhaps Argentina, maybe Jamaica, and return to the prompt and resource that file. Now it lists the extra countries, the new countries, and it's not sorted. If you wanted to sort this, there are other utilities available, such as piping this into sort to have the sort utility sort it for us. As you can see, it just cycles through it the way it's presented. Now if you sent this into sort, Argentina, Australia, France, Jamaica, Latvia, USA, it's sorted nice and clean for you. So there you have a basic for loop, and if we want, we could send this sorted output to a file. Let's say countries.txt, and now the standard output has been redirected. We now have a new file called countries.txt, which we can cat, and as you can see, it's nicely sorted, Argentina through the USA. Excellent. So that's a little bit of for loops. Let's do some more complex stuff with our for loops. The next example we want to show you is we want to cycle through a list of files in, let's say, the current directory. So we'll copy the forloop1.shell script to forloop2 to have a second shell script. And then we'll work with forloop2 so that we don't actually destroy the contents of forloop1. Let's pico forloop2, and we'll make some changes in this file that will help us to understand some more about for loops. So here's a basic for loop, cycles through the countries, sets each country on the right to the argument countries, and this could be anything, as long as what we echo or make use of within the body of the loop matches the actual argument name. Now what if we wanted to look at the directory listing using some of the techniques we've shown you thus far, such as command substitution? Let's erase everything here. Now we're using pico. Similar to nano, you can use Control-K to get rid of the lines that exist. And let's start a new for loop. We'll say for file, and there's nothing magical about file or the name file. It isn't a reserved keyword. It's simply an argument name that we're specifying. So don't think that file has some sort of significance in regards to bash processing. It's just an argument name. So for file in, and here's where command substitution helps us out. We can substitute in the output of ls with the A option or any option to create a list. That list will then be cycled through using the for loop. So for file in ls-a, I like to use -a because it ignores the implied or the implicit dot and double dots directories. Although when you do cycle through a directory listing using for loops, otherwise known as, or also known as globbing, the implied directories are overlooked anyway or ignored anyway. So there's really no reason to put ls-a, it's just habit. So for file in ls-a, we want to do something. New line do, and let's actually echo the files that are seen in this particular directory. Now we don't need to specify a directory. And we'll just echo, we'll just say done here. We don't need to specify a directory, and you should see why. Wherever we run or source forloop2.shell from, so whatever directory we happen to be in when we source it, ls will operate on. So there isn't anything hardwired here such as directory name. I mean, we could, if we wanted to specify a directory name by way of variable, we could set a directory. For example, we could set a directory, call it dir is equivalent to /etc, and then down here, it's good to separate this with quotes, and then here, but I'm going to rem this out, we could do it later. Here we could actually say ls-a on the variable dir. This would force the ls command substitution that's running here to operate on /etc. But for now, we just want to run with the current directory. So let's get rid of this line and show you how it works. Okay, so we'll source forloop2.shell. Now look at what happens. it lists all of the files that are in this particular directory, including the directories. Here you have different entries. If we do a normal ls, fine, but it lists everything that it finds here on a different line. And if we want, we could echo it, send it to sort, do whatever we want with it. ls by default will sort the commands or sort the entries found within the directory as a function of its command in alphabetical order. And as you can see here, it is. Excellent. So we have this set. So we've cycled through this particular directory. We've listed the files, the directories that are here. Notice that the directory with spaces was interpreted as four separate entries. Well, in fact, there's 5 separate entries. So that's something to look out for. If you run a for loop on directory entries, be sure that you use proper escaping so that the entries aren't echoed as or returned as separate lines. So that's one way to cycle through a directory. We could cycle through a totally different directory. Let's modify for loop 2. We can set the example we showed you earlier. dir is equivalent to /etc. And within the for loop, we can just tell it to operate on the variable dir, which is currently etc. Run this particular for loop. We'll source it, for loop 2, and have it operate on /etc. And here you find the contents of /etc. And we can do other things with it, such as counting the lines returned. You'll see how many entries are in there, whether they're files or directories. Those are the number of entries in /etc. So you know how to cycle through manually or explicitly defined values, such as countries, USA, etc. You also know how to cycle through a returned list generated by command substitution. The premise is no matter how the list is obtained, as long as it's in list format, so the values simply need to be separated by white spaces. Once they're separated, then the for loop will operate on those items as if they were separate elements, and it'll do whatever you want to do with them, such as echoing it or counting or whatever. And what we'll show you next is some more examples. We will cycle through a newly created file which generates a sequence of numbers. We'll also set counts. We'll parse the /etc password file, all within a for loop, just to show you its list processing capabilities. Now let's show you some additional examples. We're still within for loop 2.shell, which essentially cycles through a directory listing and echoes the arguments one element at a time. Let's Control X. We'll save the changes. We're going to create a new for loop file or for loop shell script called for loop 3.shell. We'll copy the contents of for loop 2 to for loop 3, just so that we can preserve the different for loops that are here. And we'll operate on for loop 3 to do some other cool things. Now let's say, for example, we wanted to generate a sequence of numbers and have our for loop echo those numbers for us. You may be wondering, how can you do it? Well, in Unix there's a command, and Linux there's a command for everything. There's a command to generate all sorts of data, and what we'll do is as follows. We'll define a new for loop. Let's blast this one. Write a new for loop. This one will be called for num, or number, whatever you want your variable or argument to be. For num in, and we're going to use command substitution again because there is a command that's available on the Linux system. You'll find it across Linux systems or Linuxes. It's called sequence, SEQ. So we're going to do for num in command substitution with backticks. We could also use, as I've shown you before, $ open paren, close paren. That'll work as well for command substitution, either or. So we'll say for num, just that backticks look more elegant. For num and requires fewer characters. For num in sequence. Now the sequence command is pretty simple. You can simply specify a start and a finish. So we'll start at 1 and we'll end at 100. You can also specify increments such as skip every few numbers if you want. But we'll go with the basics. So for num in sequence 1 through 100, do something. We'll have it do, and we've been defaulting to echo because what's important when you're learning any sort of programming language, whether it's a scripting language or a full-fledged programming language, is the ability to echo the output or to to display the output of what you're doing each step of the way until you gain confidence. And even when you become very proficient at scripting or programming, you still tend to echo the output of a particular step or many steps so that you can debug as you go along until you know for certain that the program works. So let's echo num. In this case, we'll echo num, and num will be whatever value at whatever point in time. And after we've echoed num, we'll simply end the loop. So what happens here? For num in sequence 1 through 100, sequence 1 through 100 creates an output with a listing of numbers from 1 through 100. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way up through 100. So for each iteration of sequence, the for loop sets num to that particular element. So num becomes 1, then it does whatever we want it to do in the body. It goes back to the top of the loop, num becomes 2. That's the whole idea behind looping. But you need to understand within Bash that for loops cycle through lists. For loops are designed specifically for lists. We have other types of loops, while, until, that can help us out with other types of values like running, for example, if the error level is 0 or if it's not 0, so some sort of conditional. But a for loop essentially within the Bash environment cycles through a list of values. And those values can be numeric or alphabetic. So alphanumeric. There is no difference as far as Bash is concerned because variables or within a Bash environment are untyped, whereas in most programming, full-fledged programming languages, variables are typed. Within Bash, they're not. Excellent. So let's exit here and show you what happens. This is for loop 3.shell. We'll source it. Let's use the source command. For loop 3.shell. Now notice what's returned. Doesn't look like much, but the for loop has essentially gone through the values 1 through 100. Now you could have obtained this output from the shell simply by typing sequence 1 through 100. It does the same thing, but we have a shell script to cycle through the output for you to show you the complexities of command substitution, along with the nature of a for loop to treat each element and store it in an argument. Now let's do some more with for loop 3. You can echo some more text around the actual outputted variable. So you could say, for example, the current number is, or the current number generated by sequence is, and then you'll see the number. This doesn't say much, but you know what? It gives us more control. Now let's run this, and now you get the current number generated by sequence is. The current number, so this proves to you that the for loop is in action. It's actually cycling through each element of the output that sequence provides. Now there's some other examples. We can set a count, which we'll do in our next example. We're going to parse through the /etc password file. So let's exit to the shell, and we'll copy for loop 3 to for loop 4.shell. Now this is a good way to program or to learn programming. Simply start with one script and keep copying it, and eventually you have many scripts, and then you can further tailor them. Let's modify for loop 4. And we want to get rid of the for loop that's here and create a whole new for loop. Now in this for loop, what we're going to do is we're going to use command substitution. You'll find that command substitution is used heavily, which is why we spent a little time focusing on command substitution. There are all sorts of expansions that are available to the Bash shell. Brace expansion, tilde expansion, arithmetic expansion. But by far, you'll find that you use command substitution more than any other expansion, because Bash is not necessarily highly proficient at math or parsing, but it is good at command substitution. So you open these subshells to gain output and return it to the main script. Command substitution is very important, so we use it a lot. So in this script, what we want to do is as follows. It's a for loop again, and we're going to set a variable called user, because we'll be cycling through the /etc/password file. So for user in, and we begin command substitution with opening our backticks. So for user in, and we'll just use the cat command because the cat command can open any text file and echo its contents for us. We'll cat etc password, and we'll just end with that for now. We'll just cat etc password. So for user in etc password, do something. We'll echo user. We'll show you what this looks like. This will be ugly initially. Do, and we'll just echo user. But we want to tailor the content. We want to further tailor it, but you got to begin somewhere. So this is very basic. Nothing much is happening here. The output will be horrific. For user in cat etc password. Now, etc password contains many fields that are delimited by colons. So what you'll see is pretty ugly. Let's try it. We'll source for loop for.shell. Now look at the output. This is totally unusable, totally unreadable, I should say. However, here are the users on the system. The etc password file, as I mentioned, is delimited by colon, the colon character. And these are different fields. So we need to find some way to tell our script to go in there, to open the etc password file, and to pull out perhaps the first column. The first column actually contains the username, or maybe some other column, but we're interested in the username. So let's show you how that's done. Let's edit for loop for.shell again, and let's get a little bit fancier. Now typically it's not good practice to store long values such as directory paths within your command substitution or within the body of the script. It's a good idea to store directory paths in previously defined variables. So let's set a variable. This is very good practice and it's cleaner. So we'll say directory is equivalent to /etc, or file in this case. Let's call this password file or pass file. That should work. Pass file is equivalent to /etc/password. And we'll close quotes. And in here we'll just substitute our newly created variable pass file. So we'll say cat pass file, but the output isn't clean. So we're going to use piping to send the output of pass file into the cut command. But this isn't complete. We need to say we want field 1. Field 1 contains the actual username, and you don't need to memorize these arguments. Simply run cut -- help or man cut, and you'll see that in order to extract a particular field, such as field 1, you need to specify the -f argument and the number of the field. But we're not finished yet. We need to specify the delimiter. In this case, the delimiter isn't a white space. The delimiter happens to be a colon. So we've specified here that the delimiter is a colon. This just teaches the cut command how to separate the fields. That's all it does. No different than if you were using some other parser such as awk. You'd have to actually tell it what the delimiter is. So great. We're using command substitution. We're going to and variables. We're going to cat etc password. But before we make use of it, we'll send it to cut. We want field 1. And in order to obtain field 1, the delimiter is a colon. When that's all said and done, the user argument to the left will become this new outputted value. Remember, command substitution essentially substitutes the command itself with the output. So we've cleaned up the output. Then we'll echo the user. Let's try this. We'll source for loop for.shell. And now look at the difference in the output. Here are the users. These are all the users that you'll find in our etc password file. Now we can run this command from the shell, and of course it'll work. Anything you pretty much can do in the script, you can do at the command line. Let's show you that. We'll cat etc password. We'll send the output into cut, not WC. We want field 1, and the delimiter in this case happens to be a colon. Now look at the output. It's the same thing. But we're not done. There's more we can do here to make use or to present more nicely or more useful information in the output stream or the output of the script. What if we wanted a count of the total number of users? Simply echoing the user is not enough. The user of the script may want a count. It's quite simple to ascertain the count. Now let's show you another technique you'll commonly use within shell scripts, within loops. we're going to define a variable called count. And that variable will be defined before the for loop begins. So we'll call this variable count. We'll say count is equal to 0. So we've initialized this variable count to 0 before the for loop begins. Now what we need to do is actually increment after each iteration. We need to increment the count variable by 1. So every time it cycles through, count needs to be incremented by 1, so that when the for loop finally exits, we have the true value of the count of the number of users. Certainly we could pipe this output to the WC command and it would return a number of lines, but we can also do it within our for loop. So let's increment. This is how you do the increment, or one of the ways you do the increment within a bash shell script. The command is called let, and then you open double quotes, specify the name of the variable. In this case it's count, and then you simply specify plus equal 1. So what this says is as follows: let count plus equal 1. So increment count plus equal 1. Excellent. Now let's attempt to run this without any further modification. We'll need to, of course, echo the value of count when it's all said and done. Well, somewhere towards the bottom we can specify here there are count users registered on the system. Now let's source for loop 4.shell, and here the very last line says there are 42 users registered on the system, and we spelled system incorrectly. We can modify that. Now, of course, there's more we can do. So let's go through this logic again. Before the for loop begins, we initialize a variable called count. We have to initialize it because if we don't, when we run the let command, count will be unable, or the let command will be unable to increment count because there will be or would have been no such variable called count. So we initialize count to 0. And we initialize to 0 because we don't know what the count is. Now as the for loop cycles through the output of this command substitution stream here, it keeps creating new records, or it keeps returning values. Every time it returns a value, or for each iteration of the loop, and the iteration of the loop happens between the do and the done, for each iteration, increment count by 1. Well, there happens to be 42 iterations, 42 lines within /etc password. And we can fix the typo, no big deal. And that's pretty straight. Now you can verify this from the prompt, cat etc password, and simply pipe the contents to wc-l. It'll count it the same way. It'll count the number of lines. But what we've done is, within our loop, we've echoed the output of etc password. We've told the cut command to just extract field 1, and then we've counted it. By doing the following here, catting the file and sending it to word count, we're not actually cleaning up the output. All we're doing is counting lines, and we'll show you that. We can cat etc password and look at what happens. The entire file is exported. Now when you pipe it to wc-l, it doesn't clean it up. All it does is count line after line. What we did within our script was we had cut operate on each line and told it that the delimiter was the colon, and to extract for us field 1. We could have extracted any other field, such as 2, 3, etc. Now let's show you that since we brought it up. Let's edit this here, and we'll still get back a value of 42 because there are 42 lines. Let's say we wanted field number 2. We'll take field number 2. We'll show you what happens here. Let's source for loop 4.shell, and we get back all X's. Now, by default in the Red Hat system and most Linux systems, or at least most modern Linux systems, shadow passwords are enabled. So the X's in column 2 simply indicate that shadow passwords have been enabled, which means that the passwords are not stored within the /etc password file. So as you can see, for each user here, the second column contains an X. We can pull, for example, a different, more meaningful column, such as field number 3, which actually should return the user ID, source the for loop, and now we get the user ID of all the users on the system. And of course, the very first value is 0. 0 across all Unices and Linuces corresponds to the root level user. Excellent. So now we have a nice script, a new script. It's real simple. Has some commented areas up top. It has a variable called passFile, which specifies the password file, which we could have put here, but it's just nice and clean if we do it up top. So if we wanted to operate on a different file, we could. We have a count initialized to 0. We set up a for loop. We have command substitution going on here. We iterate through the loop. We echo the user. We could have echoed any other thing we wanted, such as the current user is. We've incremented count. And then when the loop has exited, we then echo that there are count users on the system. Now, one last thing before we head out of the for loop section to move on to other loops. When you source and run the for loop, recall, as is the case with any command on or within your bash environment, the question mark variable is available. So if you wanted to check the error level or do something based on error level, it's available. It came back as 0. It's also good practice to actually echo the error level by exiting all of your shell scripts with an exit command. So in other words, if your shell script has gotten this far, it's good practice to simply exit with a code to control the exit, just in case something goes wrong. I mean, if there were problems earlier in the script, it would break at an earlier point. So if we run the for loop, then it exits. Now in this case, we did this purposely to show you what happens. When you run a script within a shell, and it's the only shell, with an exit 0, it actually exits. So it closes the shell. So that's a good note to end on. So we will move on to while and until loops in the following sections.